Hello, dear students. Welcome to another video discussing the solution of IIT JAM 2025 economics paper. As mentioned in my previous two videos, where I have discussed your MCQs from question 1 to question 5, question 11, question 13, and others, I have mentioned the importance of solving PYQs before you go and appear for IIT JAM 2026 examination. Solving PYQs once is not enough. You have to solve it at least 2 times before your real examination. The first time you have to solve them when you are studying for the subject, whereas one time you have to solve them once your syllabus is completed and you're doing your revision. In addition to this, solving PYQs is not the only thing that can save you, but your conceptual clarity also needs to be strong. So for our students, we keep posting, we keep sharing PDFs from the concepts that help them to feel comfortable with the most difficult concepts from IIT JAM syllabus. So if you also want to get those PDFs for free, you can download our app, Ecoholics. It is available on Play Store as well as App Store, both Android and iOS. And you can very easily have access to all those PDFs. Now in this video, we are going to discuss section A, that is your MCQs, which are for 2 marks each and with a negative marking of 2/3 marks. We are going to discuss question 12, question 14 and question 15 in this video. So let's get to the video and start learning together. If beta hat is a consistent estimator of a population parameter beta, where epsilon and delta are very small quantities, then you have to choose the correct one. Now remember, epsilon and delta are very small. And beta hat is a consistent estimator. What do we mean by consistent estimator? It means that when the sample size is going to be infinite, when the sample size is going to be increased, beta hat is actually approaching beta. It is as closer to beta. Okay, so that is the consistent estimator. Now, if we go through all the 4 options, now they're not asking you any concept, they're just asking you to choose the correct one. If you look at all the 4 options, what is common? Probability, 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 probability. This is difference between the estimator and the true population value. And the next thing which is common is that this difference is always less than epsilon, always less than epsilon. The only difference comes in here I have 1 minus delta, here it is 0, here it is delta, here it is 1 plus delta. Now remember one thing, I would like to tell you one thing. If they have given delta, there are high chances that delta will be used in the answer. But it is not going to be the case every time. So also do not make wrong choices by this fact. Tell me one thing. What is the definition of a consistent estimator is? For a consistent estimator, the probability of the estimator and the difference from population parameter, over here we are saying that this should be less than epsilon, where epsilon is a very small value. So this probability should be higher, which means it should be 1, let's say. So that is a consistent estimator. Now, if you go through all these options over here, which option is giving you the answer closer to this? 1 minus delta, 0, delta, or 1 plus delta? Now remember one thing, 0 I won't choose here because this probability can't be 0. Delta B I will not choose. Of course, I want this probability to be 1. It means I want this probability to be on the higher side. I want it to always happen because. So these 2 options are ruled out. Now talking about 1 minus delta and 1 plus delta, students are going to get confused into this. Right? Correct? So 1 minus delta, since delta is a very small number, so if I subtract it from 1, you're going to be closer than 1. You're going to be closer to 1. And this probability will be equal to that. Right? So let's see the detailed solution over here. This is the definition of the consistent parameter. This is the probability limit of the consistent estimator. All right. So the option A defines the consistency of beta hat, because this probability has to be at least, it can be greater than, it can be equal to 1 minus delta, because delta is going to be a small number. 1 plus delta ke equal it cannot be. It cannot be equal to 1 plus delta, right? Because probability is always between 0 and 1. So 1 minus delta will give me a value less than 1, but it will be closer to 1. That is the point here. So according to this, according to this, 1 minus delta, which is my option A, becomes my correct option. So even if you just know about a consistent estimator, you just have to read through all the options before you decide the correct answer. So n approaches infinity is common to everywhere. So this option A becomes my correct option. Is this clear? Now, coming to question number 14. So question number 14, this is your Cobb-Douglas production function. So rewrite it as L raised to the power alpha and K raised to the power beta. So this is a Cobb-Douglas production function with two factors, that is labor and capital. Then the presence of constant returns to scale is exhibited by the production function, and that can be tested using only t-test statistic, only f statistic, both t and f statistic, or chi-square statistic. So that's what we have to decide. Now, when does constant returns to scale happen? Constant returns to scale happen whenever alpha plus beta, the sum of these elasticity coefficients, is equal to 1. It is equal to 1. That is the case of CRS, constant returns to scale. Now, how do I test that alpha plus beta is 1? Now, if you will see, this is a function where I will have to take double log on both sides. Okay, so this is a club of microeconomics and econometrics. In econometrics also we read regression models about double log model. So it's an application of that. So I will take log both sides. Log y is equal to alpha log L plus beta log K. Now this is what I have. Now remember one thing. If I have to individually test them, then I will use t-test statistic. But if I have to use them in a joint hypothesis, then I will use the f-test statistic. So both t and f-test statistic can be used to test. So null hypothesis would be alpha plus beta equals to 1, whereas alternative would be alpha plus beta not equals to 1. So this question came in Indian Economic Services exam as well, where they gave these two, null hypothesis and alternative hypothesis, and they asked to test these hypotheses. So that was basically testing of the CRS of a Cobb-Douglas production function. So I can use both T and F test statistic. T I will use whenever I have to do individual hypothesis testing, whereas F I will use whenever I have to use joint hypothesis testing. I hope this is clear here. Now let's proceed to question number 15. So detailed solution, you can see here that if you want to use individual testing, t-test statistic. If you want to use joint hypothesis testing, f-test statistic. Now question number 15. In the context where sample mean of dependent variable lies closer to observed y than its least square predictor. Now this question seems confusing, but I tell you how to read it. Read it in bits. In the context where sample mean of dependent variable lies closer to observed y. So the sample mean, which is y bar, a bar will come here. So y bar is closer to y than it. So we are comparing. Than its least square predictor. So least square predictor is the expected value of y given xi in the regression, right? So than y hat. So which means y hat is not closer to y, but y bar is closer. So sample mean is giving me better estimation of y than my the regression value of y, the predicted value of y. So what will happen to goodness of fit in this model? So I can bet you, as soon as soon as any student is going to see this question after learning the concept of R square, they would choose the answer that goodness of it will be equal to 0. But that is completely wrong answer. Completely wrong answer. Why? Now remember one thing. R square equals to 0 means that your RSS, residual sum of squares, is equal to total sum of squares, which means the entire value is predicted by the random error term and not your predetermined value, not your non-stochastic variables, right? So that is not the case here. Over here, the case is that my model is not perfect fit. The model I'm running, maybe the model I would write here, yi is equal to beta 1 plus beta 2 xi plus mu I, let's say. So the model I'm estimating is not a correct fit. That is why what is happening? That the y hat is not coming closer. Instead, the y bar, if I take the sample values, that is better option. The arithmetic mean is a better option than regressor. It means this clearly shows me not choosing a correct model. In that scenario, do you know the R square becomes negative? The R square becomes negative. Hence, option A is my correct option. Option A becomes my correct. Dekho, it can't be equal to 1 for sure, because equal to 1 means prediction is closer, is equal to the actual value. So this is eliminated here. Equal to 0 eliminated here from the reasoning I gave. 0 and 1 ke beech mein, it will lie. But in this case, it will not lie between 0 and 1, but because it will be negative. So whenever your model is completely mismatched, whenever your model is not a good fit, the R square is going to become negative in that case. It means that ESS, instead of giving me some prediction, it is deviating me from there. So if you wish to see the detailed solution, you can read it here. You can read it here. This will be 1 minus. All right. So option A is the correct option. Now, with these 3 questions, you have learned about estimators. So all these 3 questions were applications of regression as well. So what we did, let's take a quick revision. What we did, we talked about consistency of estimator. We talked about the test statistic I can use to test hypothesis testing. And then at the last, we talked about the case, the R square being negative. So let's take a quick revision of what we have done Let's take a quick recap of what we have done. Let's take a quick recap of what we have done using these 3 questions. We learned the consistency of estimator. We talked about the test statistic for hypothesis testing. And then we have discussed about the characteristic or the value my R square can take. So I hope you have learned new things after watching this video. As I mentioned earlier, we are going to share more solution videos for IIT JAM 2025 series. So if you wish to get those videos on time, please subscribe to our channel. On our app, you can get handful of PDFs that will help you in your preparation, that will guide you for your strategy, that will help you clear your basics. So please download our app and have access to all those PDFs in free. I will see you in the next video. Till then, if you find this video useful, do share it with your friends as well, so that they can also understand these concepts. And I will see you soon. Bye, everyone.